this ordered pair right here is 0a, that means the y value is what? A, right? That means the length of this segment is A units long. So if it's a square, how long is every side? A units. So what's the ordered pair to Z going to be? Oops, sorry, I had that written. A0. And what's the ordered pair to W going to be? How long is this side? Jeffrey, how long is this side right here? Listen to the 6 people around you. How long is that side right there? Thank you. What'd you get, Jeffrey? What do I write here? How long is this? A. And if this is A, then to get to this point here, I would go how far this way? How far is this? A. And how far is this?
A.
So the ordered pair is? AA. Now I know I heard people saying that, but I also know a lot of you weren't paying attention yet. So how many variables did it take to identify the 4 coordinates of that square? 1. It took 1 variable. Length A. This point here, what is that? 0, 0. Okay? So that's what we consider conveniently located. The least number of variables it would take to describe it if you didn't know how long each side was. Okay? So looking at the second slide there, if this is a trapezoid, looks like an isosceles trapezoid, okay? It's conveniently located for us. This point right here is A0. That means how far is this? A. If this point over here is negative A0, how long is this side? A. Right? The negative just means direction, correct? Okay? And so, if this point here is BC, then that means they went how far this way to get to there? How far is this? B. And how far is this? C. So if I go over here and up, what are the coordinates to W going to be? Louder?
Negative B times C.
Nice. So I would still go B units this way, but it's left, so it's negative B. And I still would go up C units, so it's C. So my coordinates to W would be negative B, or it's actually opposite of B, because we really don't know what B is, right? So when a negative sign in front of a variable, normally you try to read it as opposite, but here we know we're going a negative direction, and I'm okay with you referring to that as negative B. How about Z? What's the x coordinate to Z? 0. And how far up did I go to get to Z? C. Okay. Any questions on that? Now they're going to ask us to find the midpoint. The midpoint of, say, W, we'll call this, we'll call it R. Doesn't matter, we just need to label it. We want to find the midpoint of RW. Okay? Midpoint of RW. Let's jump ahead here, midpoint formula. Remember how to find midpoint? Anybody? This is scary. Are you going to remember my name in a week or 2 weeks? Come back from Christmas?
No.
What do you think?
It's 1, 2 minus 5, 1 over
That would be the slope.
Oh.
Okay? I was standing in your way. That's the slope formula. Let's find the ratio of the rises to the runs. That's what you're doing. Okay? Midpoint formula means x1 plus x2 over 2 and y1 plus y2 over 2. So in other words, we find the average of the x's and the average of the y's. And before we move back to that other question, let's go ahead and find the midpoint of these two coordinates. Someone hasn't volunteered information yet today. Tell me how to find the x's. What would I write in the first one?
3 plus 7.
3 plus 7. That's it?
Over 2.
Over 2. Okay? Someone knew, how would I write the second part to find the y's? Yeah, go ahead, Simon.
5 plus 3 over 2.
5 plus 3 over 2. Now, just because sometimes it matters in the things we're doing, you should stay in the habit, if you decide to go 3 and then 7, go 5 then 3. Although I'm not going to pretend it matters in this case. If you're adding two numbers, it doesn't matter which order you add them. But in a lot of things we do, it does matter. So if you just get in that habit and always do that and always go in the same direction, it'll make less mistakes when it does matter. What's 3 plus 7?
10.
And 5 plus 3. And what is 10 over 2? And 8 over 2. And so we get 5, 4 to be our midpoint. Okay? Now if we go back to this problem, what's the coordinates of R?
Negative A, 0.
Okay, what's the coordinates of W?
Negative B, C.
Negative BC. So the midpoint, if I do the x's first, what do I get?
Negative A plus negative B.
Negative A plus negative B over
2.
2. What's the other side?
0 plus C.
0 plus C over 2. And so, if I clean it up, can I combine negative A and negative B?
No.
No. I can't. I could say, hey, they both have a negative in. I could move that negative out and say A plus B over 2. I could do that if I wanted to. Does that make it simpler? I don't know. I don't know that it does. Okay, so probably I wouldn't even bother doing that. I'd just write negative A plus negative B, or negative A minus B. But what is 0 plus C? C. So that one does, okay? That one does do that. All right? Okay. Any questions on that? Now, if you were selecting the points, if you were asked to place this, and you knew you had to be finding midpoints, you might not want to call this A. You might want to call this 2. You might want to call it 2A. Because what's half of 2A? 1A, right? So if I don't want to end up with fractions at the end of my midpoint, I might start out with 2A instead of 1A. So depending on the situation, what they're asking for, you might consider that before you choose your variable. Okay? So the next one, number 4, I don't know what they're asking. Let me look. coordinates of W and Z without any new variables? Oh, okay. So he just wants to find W and Z. Okay? So the question is, how far is this?
B.
It's B, right? Because if I went to this point, I would go over here and then up to there, right? And how far is this?
B.
B. And so if this is B, then over here is B. So the Y value of W is B. What's the X value?
0.
0, because it's where? On the Y-axis, right? Didn't move left or right at all. It stayed right on the Y-axis where X is 0. Okay. Now Z is a little more confusing. How far is it from here to here?
C.
C. And from here to here, this distance here is C minus A. That means this distance here is how long?
A.
A. Okay? Let me glance at their picture, make sure I copied the picture right. Oh, I did. What I had overlooked, I said this distance here is C minus A, right? And so you're right, this is A then. C minus A puts us back to this point. But this distance here, this length right here, is the same as that length right there, isn't it? So how long is that side of this parallelogram? C minus A, right? And so if I move it over here to C minus A, you agree? C minus A, then this unknown side here, this unknown distance right here, and this distance here have to add up to C, don't they? Okay? So question mark plus C minus A has to equal, I'm sorry, C, not A. Has to equal C. This distance right here. Okay? All the way across. So if I add up this little bit here plus that yellow line, I have to get the length of C. So if I subtract C from both sides, I get this unknown minus A, not plus A. Unknown minus A is equal to 0 now, because that canceled. If I add A to both sides, I get my unknown side to equal what? A. And so what I've done is realize that the distance from here to there is A. It's the same as that distance right there. Okay? So what's the coordinates of Z? I've got a lot of mess here, but right there's Z. How far is this? A. And what's my Y? 0. So the coordinates of Z are A, 0. Coordinates of W are 0B. The W was easy to see. The Z was not quite so easy. I'm sure there's other ways of looking at that. That's what popped into my head to try to help you understand where I got that. Okay? Make sure you have the, oh, you have them written down. I gave this copy to you. You've done slopes and distance formula before. Do I have to practice one of those with you? For anybody? Okay. When you have to label the vertices, be careful what you choose for your labels. This is what he's talking about. If we just want to label this and it's a rectangle, then I might call this A0. I might call this 0B. And so this one here would be what? AB. Okay? But if they want me to find the midpoint of this and the midpoint of this, then I probably don't want to label it A and B. I probably want to label it 2A and 2B. Because what do you do when you're finding the midpoint? You divide by 2. Good answer. Okay? You divide by 2. So if we double everything in the beginning, we divide by 2, we get nice numbers instead of fractions. I should say nice variables instead of variables in a fraction. Okay? So that's all I mean by this. Choose them wisely. Yoda says choose them wisely. Okay? Actually, it wasn't Yoda. Who says choose? Oh, it was Indiana Jones, right? Choose wisely. Get all the Holy Grails there. Not the Holy Grails. Was it? Okay. Anyway, all the old cups. You had to choose one to drink out of. All right. So understand what they're asking for before you pick your variables. Okay. Think about what you're going to be doing. And sometimes think about this. If I'm going to then find the midpoint of this one, so I'm finding the midpoint and then finding the midpoint again, what might I start with instead of A? 4. If I'm going to find midpoints and then find midpoints again, I want to start with twice as big 2 times. So twice as big would be 2A's, and then twice as big again would be 4A. So when I find the midpoints here, I get a 2B. And I find the midpoint here, I get a 2A and 2B. And then when I come back to here, I end up with A and B. Okay? So just think ahead before you choose your variables. That's all I'm saying. All right? And in that space next to the side of this, you should write a note of what I'm saying here. Don't just look at me, watch and listen. Make a note to yourself. If you're finding midpoints, you might want to start with 2A and 2B instead of A and B. If you have to find midpoint twice, start with 4A and 4B. I'll pause while you write yourself a note. Okay, let me pause a second. I did not write this down. This is on page 5. This is on page 332. I want you to turn to page 332 and off to the right. I want you to actually write the mid-segment theorem for the trapezoid. We did this in a homework question a few lessons ago. We talked about the mid-segment of a trapezoid. And it was leading you to think this way. 332. All I wrote down is what is true. And what is true is that the mid-segment, MN, connects the midpoints of these now let's try it again. Connects the midpoints of these non-parallel sides here. And so that makes it a mid-segment of this trapezoid. And it makes this mid-segment parallel to the other 2 sides and half as long as their sum. So if I added these 2 sides up, this length is going to be half that length. So in other words, it's going to be the average of the 2 of them. Add them up and divide by 2. Okay? So you have this slide, but off to the right, copy down on page 333 the way it's worded there. So you have wording to go with what these symbols are. Okay, any questions on what's going on here? So how long is the mid-segment of the trapezoid going to be? Half of what? Louder? Half of what? The length of the bases. Good. And the bases are the parallel sides. So it's half the length of the bases added together. Okay? So if you added up the length of the parallel sides, the mid-segment's going to be half that length. Okay. Little slide here reviewing some concepts. Parallelogram. Opposite sides are parallel. Okay? And then we have some properties. Opposite angles are congruent. Diagonals bisect each other. If they bisect each other, what does that mean? Here's a picture of it. If these two bisect each other, so this is my poorly drawn parallelogram. Those diagonals bisect each other. What does that mean about that? How does that help me? What information does that mean? Tell me. If they bisect each other. Opposite ends are congruent, okay. How about where they meet? You're saying these opposite ends here are congruent, and these opposite ends are congruent. I agree with that. But what's it say about where they meet? It's the midpoint of what?
B, A, and C, D.
Yeah, in other words, both diagonals, right? That point right there is the midpoint of both diagonals. So what's an easy way to determine whether they bisect each other? What have we done just not too long ago today? We found the midpoint, didn't we? Do you have the ability to find a midpoint? If I wanted to know if these bisected each other, and I didn't have these marks here, I just had two diagonals, so it looked like this. And I want to know if they bisected each other. If I found that to be the midpoint of each one, then that would mean that they bisected each other, right? And I could take these 2 points and find the midpoint, right? And I could take these 2 points and find the midpoint. And if I get the same point for both of them, that means they have the same midpoint, doesn't it? That would mean then that they bisect each other, which means this is equal to this and this is equal to this. That would mean this is what shape? If they bisect each other, what shape is that? Actually, a parallelogram. Okay? It's a parallelogram. We don't necessarily know that it's a rhombus. To be a rhombus, they would have to also be perpendicular. Remember? The rule for a rhombus is they're perpendicular. There's a lot of information in this lesson, and that's why I'm telling you we're not hammering you on the test on this stuff. You've not had adequate time to grasp everything completely, but you need to know some general rules about it. So the rest of that slide is just reminding you of the rules to be a parallelogram. To be a rectangle, all angles are 90 degrees, which means the sides have to be perpendicular. Okay? And the diagonals are congruent. And here's the distance formula again to help us find length, to know if they're the same. And this right down here is important. Slopes of parallel lines are equal. Remember that? And slopes of perpendicular lines are opposite in sign and reciprocals of each other. In other words, they use that flippy switchy thing. You remember that? That flippy switchy thing. So if you find the slopes of two lines and you want to know if they're perpendicular, if you can flip one over and switch the sign and it matches the other one, then they're perpendicular. But if I get 1/3 and 3, 1/3 and 3, are these two lines perpendicular? Why not? Yeah, I have to flip it over and switch the sign, right, to be perpendicular. Just flipping it over doesn't do it. So these are not perpendicular. Not perpendicular, okay? How about 2/3? What would be perpendicular to 2/3? -3/2. Okay, remember that now? Okay, make a note to yourself off to the side. These are not perpendicular. Okay? Those are not perpendicular, these are perpendicular because they apply that flippy switchy thing. Okay? So this whole lesson is asking you, is this, if these are the coordinates of this quadrilateral, is it a parallelogram? Or is it a square? Or is it a rhombus? Or is it, and so you're going to have to think, what makes it those things? Are the diagonals perpendicular? Are they congruent? Are the opposite sides equal? Are opposite angles equal? The angles are kind of hard unless they have to be perpendicular. Okay? You can't use this type of proof to determine a 30-degree angle. But you can determine if the two lines are perpendicular, which would make it a 90-degree angle. Okay? Trapezoid. I'm just reminding you here of what it takes to be a trapezoid. One pair of parallel sides. So if I give you 4 coordinates, I say, is this a trapezoid? Well, you'd find the slopes of the 4 lines. Find the slopes. And if any of them are equal, that would make them parallel, right? And so that's what you'd look for. Slopes are equal. Rhombus. All 4 sides are congruent and diagonals are perpendicular. Okay? A kite. 2 pairs of congruent adjacent sides, opposite sides not parallel. So you would check to make sure the opposite side, you check to make sure the sides are congruent, 2 pairs of them. You'd use distance formula for that, right? Remember distance formula. x2 minus x1 squared plus, you've got this written down 3 or 4 times there, so don't worry about it. y2 minus y1 squared. Okay? That's distance formula. So we'd use that to find how long the sides are. And if we have 2 pairs of congruent sides, and we check their slopes to know that there aren't any parallel sides, then it's a kite. Okay. Let me pick a few problems. Okay, remember what I just said. Your assignment is a group assignment, so as a group you need to have these all done. All done. I will not give you any points on your notebook check if you have one of these missing. Okay? There's 3 or 4 of you in each group. There's 10 questions here. Sorry, there's 11 questions here. Okay? Expect them all to be done. Not 90% of them. Okay?